Hello friends, good evening. I, Dr. Mohammad Shahar Yar from Jamia Hamdard, am going to explain electrochemical methods of analysis. First, we shall discuss about learning outcomes, in which we shall cover what is electrochemistry, followed by brief introduction about different techniques which follows electrochemistry, then types of electrochemical methods, and then general applications altogether of all the techniques. First, we shall talk about what is electrochemistry. Electrochemistry is branch of chemistry which deals with the interaction of electrical and chemical effects. It involves the study of chemical changes caused by the passage of an electrical current and the production of electrical energy by these chemical reactions. Electrochemical methods are analytical techniques that use a measurement of potential, charge or current to determine an analyte's concentration or to characterize an analyte's chemical reactivity. It is originated from the study of movement of electrons in an oxidation reduction reaction. It is qualitative as well as quantitative method of analysis which is based on electrochemical phenomena occurring within a medium or at the phase boundary and related to changes in the structure, chemical composition or concentration of the compound being analyzed. Now we shall talk about certain features of electrochemical techniques. In all techniques, we use different type of instruments. However, there are certain common features which includes the electrode potential determines the analyte's form at the electrode surface. The concentration of analyte at the electrode surface may not be same as its concentration in bulk solution. That means it may be partially oxidized or reduced. Current is a measure of the rate of analyte's oxidation or reduction. However, there are certain drawbacks. The highlight of that is we cannot simultaneously control current and potential. Now, types of electrochemical techniques. There are two major types of techniques. One is bulk techniques and other is interfacial techniques. In bulk techniques, we measure a property of the solution in the electrochemical cell. Conductivity or conductometry is one of the example of bulk technique. Whereas in interfacial techniques, we use potential, charge or current depends on the species present at the interface between an electrode and the solution in which it sits. It includes so many techniques. One of them is potentiometry. Interfacial electrochemical technique is further subdivided into two parts. One is known as static technique and other is known as dynamic techniques. Static technique includes only potentiometry in which the current is not passed through the analyte's solution and in which we measure the potential of an electrochemical cell under static conditions. Whereas in dynamic techniques, we allow current to flow through the analyte's solution. It comprises the largest group of interfacial electrochemical techniques such as coulometry, in which we measure current as a function of time, and amperometry, in which we measure current as a fraction of a fixed or variable potential. Now, we shall learn briefly about all these techniques. First, we shall take up potentiometric titration. It is similar to direct titration of a redox titration that we normally use in the laboratory using burette and conical flask, etc., where we need to use a suitable indicator. However, the advantage in the potentiometry is that it does not require any indicator. Instead, the potential across the analyte, typically at electrolyte solution, is measured. In this technique, generally two electrodes are used. One is known as indicator electrode, other is known as reference electrode. In pH meter, glass membrane electrode is generally used as in reference electrode. In this technique, potential of an electrochemical cell under static condition is determined. Since no current or a very negligible current flows through the electrochemical cell, its composition remains unchanged. Therefore, this technique is a useful quantitative technique. But the potential is then the potential which has been determined can be directly related to the concentration of one or more analyte. So, hence we can determine the concentration of a particular analyte present in the given solution. The next method is conductometric method, in which the electrical conductivity of electrolytes in aqueous, non-aqueous as well as in the colloidal system is measured. Conductometric analysis is based on the measurement of the electrochemical conductivity or electrical conductivity of the solution due to the mobility of cation and anions towards respective electrodes. The electrical conductivity is entirely due to the movement of ions. The mobility of an ion is affected by several factors. Few of them are number of ions present in the solution, their size, and the temperature at which the reaction is being carried out. Next is the voltammetry. Voltammetry covers the variety of methods, and it is the largest group of electrochemical method of analysis which is commonly used for the determination of compound in a solution. The main examples are polarography and amperometry. It applies a constant or varying potential at an electrode surface and measures the resulting current with an electrode system. In polarography, the working electrode is a dropping mercury electrode or a static mercury drop electrode, which is used to analyze solution of reducible or oxidizable substance. The second technique used in the voltammetry is amperometry, which is used for the detection of ions in a solution based on electric current or changes in electric current. It involves the application of a constant reducing or oxidizing potential to an indicator, which is generally considered as working electrode, and the subsequent measurement to the resulting steady state current. Next is coulometric method, which is based on the measurement of amount of material deposited on an electrode in the course of a chemical reaction in accordance with the Faraday's law. a distinction is made between coulometry at constant potential and coulometry at constant current. That means these are the two different types of coulometric method. It uses applied current or potential to complete conversion of an analyte from one oxidation state to another. In this technique, the total current passed is measured directly or indirectly to determine the number of electrons passed. Knowing the number of electrons passed, the concentration of analyte, or when the concentration is known, the number of electrons transferred in the redox reaction is determined. General applications of all these techniques. These techniques are used to analyze a solution for trace amount of metal ions or organic species present in the solution. It is also used to obtain thermodynamic data of a reaction and to generate an unstable intermediate such as radical ion and study its rate of decay or its spectroscopic properties. And finally, it is used for the determination of electrochemical properties of the system themselves, which are of primary interest. For example, in the design of a new power source or for the electrochemical methods have been developed. Thank you and happy learning.